in a digital world where all seems smooth and seamless. But behind the scenes, what's the backbone of it? That server. Millions of servers actually. And to safeguard the 24/7 operation of the servers, we need this PSU, Power Supply Unit.
Well, it might look quite similar to the PC case under your desk, but their design philosophies are worlds apart. Server power supplies are not about the dazzling light and decorations. Instead, we have three ultimate goals here: reliability, continuity, and efficiency. Today, we'll have a closer look into Server PSU. PSUs used for servers in large-scale data centers are what we call server power modules.
In terms of appearance, they typically feature a long, narrow form, modular design, and a metal handle.
AI is the defining theme of our era. AI server PSUs feature high power density, high efficiency, and fast dynamic response. A mainstream specification today is 5.5 kilowatt power, 54 volts DC output, 97.5% conversion efficiency, and with a current loading rate of 2.5 amps per microsecond. These are top-tier indicators.
Now, how do we ensure the functionality and performance of AI server PSUs? The answer is to be found in a series of tests, including testing of input and output characteristics, safety protections, and other functions.
We happen to have an AI server PSU at hand. Now, let's take it to the lab and see what it can do.
The test platform mainly includes E5100 series programmable DC electronic load, G6000 series bidirectional programmable AC power supply, oscilloscope, PSU. The G6000 series bidirectional programmable AC power supply supports flexible programming of voltage, frequency, and phase via its software. It can be programmed to simulate an input waveform of 200 volts AC to 0 volts AC in 0.02 seconds, 50 Hz, phase angle of 0 degree. First, we set and output a steady-state voltage of 220 volts. Then, we program a list sequence where the voltage drops to 0 volt at a 0 phase angle, holding for 0.02 seconds. Once the step is triggered, it outputs exactly as configured. The voltage waveform is captured by the oscilloscope. The dynamic load test demands very high current slope. It requires an electronic load to simulate the transient conditions of GPU loading. The E5100 series programmable DC electronic load offers microsecond-level current loading capability. To meet the dynamic loading requirements of AI server PSUs, it achieves a current rise slope of 2.5 amps per microsecond. Following the test specifications, we set up two dynamic load tests, with load changes from 10% to 70% and from 40% to 100%. Let's start the test. First test set. Configure E5100 for a dynamic current loading from 10 amps to 70 amps with a current slope of 2.5 amps per microsecond. Start the load. The current waveform is captured by the oscilloscope. The rise rate is as follows. Now, shorten the loading time. We can see the periodic change in current. Also use the oscilloscope to measure the current fall slope. Second test set, we configure E5100 for a dynamic current loading from 40 amps to 100 amps. Start the load. Monitor test data. Adjust the loading time. Now observe the waveform and the current fall slope. Through the two tests above, we have briefly validated whether the AI server power can maintain stable output during brief input power failure and rapid dynamic load changes. This is to guarantee the stable operation of the server.
Kewell AI server power test solution faces directly the challenges in testing posed by high computility. With its high precision, fast dynamic response, and reliable testing capabilities, it meets PSU test needs across scenarios. Furthermore, our solution covers 9 major application scenarios and supports product lifecycle from R&D to production with super fast current response and multi-condition simulation capabilities. Strictly adhering to industry standards, we ensure the stability of AI power supply and empower our customers with automated, highly consistent power verification. Okay, that's the end of this episode. If you like our content, don't forget to subscribe and give us a thumbs up. See you next time!